Welcome viewers, in this video we'll see the parallel subtractor using the full adder. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic parallel subtractor using the full adder. A parallel subtractor is a digital circuit capable of finding the arithmetic difference of two binary numbers that is greater than 1 bit length by operating on corresponding pair bits in the parallel. So normally by using full adder we can add 1 bit data. Two different 1 bit data can be added. If you want to perform the parallel subtractor means n number of full adders are used in the two binary number having more than 1 bit. For example, 4 bits are there mean 4 full adders are used, corresponding bits are added together. That's why it is called a parallel subtractor. The parallel subtractor can be designed in several ways, including combination of half adder, half subtractor, full subtractor, or all full adders with subtrahend complement input, right? So we can use half and full subtractor, or all full subtractor, or all full adders, right? So in this video we are using the full adders. Separate video available for half and full adder. Using half and full adder also we can perform, that is available separate video. So in this video we are using full adder. Now we'll see the logic diagram. So this is the logic diagram of four parallel subtractor using the full adders. So this full adder 1, 2 up to n is there, n number, n bit data. So this is the A1, A2, an minus 1, an is the bits of the first number. B1, B2 up to bn is the bit of the second number. So A1 and B1 is correspondingly added. Similarly A2 and B2 is added. Like that parallelly we are doing the operation, subtraction, by doing the subtraction. But here we are going to add the number, add the first digit with the complement of the second digit, that is the 2's complement subtraction. We are going to perform 2's complement subtraction. First number is added with the 2's complement of second number, so that is equivalent to subtraction. So first number is given as it is. Second number, second bit, the first bit of the second number B1 given through the NOT gate. So B1 means here become B1 bar complement, that is equivalent to 1's complement. 0 means it will convert it into 1. 1 means it converted into 0. Complement, 1's complement. Here the C in, that is nothing but carry in, right? Full adder having 3 inputs, 2 bits of the 2 number and one more carry. Here carry is equivalent to 1. So 1 is added with the B bar. So that becomes 2's complement, right? B1, well after going after the NOT gate it becomes B1 bar, that is 1's complement. By adding one more 1 with the carry it becomes 2's complement. So this is nothing but performing the 2's complement subtraction. Number 1 first bit is added with the 2's complement of the second number, so it is equivalent to the subtraction, right? Similarly it is, we are doing the operation. A1 and complement of B1, that is added with 1, 2's complement added, it will generate the sum, that is equivalent to subtraction, and it will generate the carry C2. So that is used for second bit, so that we can perform 2's complement. Then S2 is given. Similarly we are doing the n numbers. We can do n bits of first number and second number, right? So in this subtraction is performed with first number is added with the 2's complement of second number, so that is equivalent to the subtraction, right? First number added with 1's complement plus 1, so it becomes 2's complement. Now we'll see the description. What is the given? What we discussed, the details are available. We'll see the description. As shown in the diagram, the parallel binary subtractor is formed by combination of all full adder with the subtrahend complement input, right? The complement input is there. This operation considers that addition of minuend along with the 2's complement of the subtrahend, it is equal to the subtraction. First number is added with the 2's complement of second number, so that is equivalent to the subtraction. Firstly, the 1's complement of b is obtained by NOT gate, and 1 can be added through the carry to find the 2's complement of b. Right? First, using the NOT gate, 1's complement is obtained. Adding the 1 using the carry, it is converted into 2's complement. This is further added with a to carry out the arithmetic subtraction. Right? So first number added with the 2's complement of second number, that is equivalent to the subtraction. So the process continue till the last full adder FAN uses the carry bit Cn to add with its input An and 2's complement of Bn. Right? A1, B1, A2, B2 up to An and 2's complement of Bn is then added at the last bit, so that the carry is generated, that is carry out. We know that the subtraction of A by B is obtained by taking 2's complement of B and adding with the A. Right? So that is the basic thing. 2's complement of B is added with A, so that is equivalent to subtraction of A by B. Right? The 2's complement of B is obtained by 1's complement and adding 1, that is already we discussed. Right? 1's complement is got by NOT gate. By using the carry equal to 1, the 1 is added, so it is converted into 2's complement. Hence, in the circuit, 1's complement of B is obtained by the inverter, NOT gate, and a 1 can be added through the input carry. So in this video, we discussed the parallel subtractor, parallelly adding the n number of n bits of number using the full adder. This full subtractor also separate video available. Full adder means first number is added with 2's complement of second number, so that is equivalent to the subtraction. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.